Hey everybody, let's start today with a question. Here we go. All right, so we're going to be looking at our special quadrilaterals one more time today. Today we're going to focus on the diagonals of the special quadrilaterals. We learned all the properties of them yesterday, such as the rhombus has all four sides congruent, the rectangle has all four angles congruent, and the square is both a rhombus and a rectangle because it has all four sides and all four angles congruent. Today we're going to look at the diagonals and what's special about the diagonals in these special polygons. The rhombus has two special characteristics for its diagonals. Okay? The first special characteristic we get is that the diagonals are perpendicular. They intersect to form a right angle. So if I have diagonals that are perpendicular and also bisect each other, because in order to be a parallelogram it has to bisect each other, then I know I have a rhombus. So I can kind of determine the type of shape it is strictly from a rhombus, from the diagonals. The other thing that's special about that is the diagonals bisect opposite angles. Now we already know that the opposite angles are congruent because that's true for all parallelograms. But now the diagonals bisect the opposite angles. So both diagonals bisect both angles they intersect, so all four angles are being bisected. Now, as you've noticed several times, angle bisection is something we cannot do in the coordinate plane. But it does mean, since we bisect all the diagonals, and these are right angles, and they bisect each other, because they're parallelogram, it does mean that all four of those triangles are congruent in that picture, because all four sides are also congruent. In fact, we have all 6 parts for all 4 triangles congruent now in a rhombus when I put those diagonals in. So that's kind of special, is that all 4 triangles in that rhombus, when we break it up, all 4 are exactly the same. They're all right triangles. They're all exactly congruent. So that's pretty neat. How do we use that? Again, we use it to set up and solve problems, to find things out. If we're told that this is a rhombus, for example, ABCD is a rhombus, it says right there. It's a rhombus. That means all 4 sides are the same. It means the diagonals bisect each other, diagonals are congruent, and the diagonals bisect the angles. So angle 1 here has to be 90 degrees. Angles 2 and 3 have to be the same as the angles down here at angle C. So angle 2 and angle 3 both are 61 degrees. And once I have this triangle here, I'm just expanding that triangle, that is a 90 degree angle here and a 61 degree angle here. It's pretty quick to figure out this angle must be 29 degrees down here, angle 4, because they have to add up to 180. So we can use all these facts about our triangles inside rhombuses. Holy smokes, what are we doing? We're going back to triangles again. That's the way it's going to go all year. We learn about one shape and then we refer back to triangles. Always works back to triangles. And once we know all that, find the measure of angle ADC. That'd be this angle here. Obviously, since this is bisecting, the DB is bisecting the angle here, these 2 angles have to be congruent, so 29 and 29 is 58. And BCD, again, since this is a bisector, this must also be 61, so that's 132 degrees. So everything very consistent, but again, all of these conclusions are based upon the fact that this is a rhombus. If this is a rectangle or just a plain old parallelogram, the only thing we know for plain old parallelograms, I can't speak, is that the diagonals bisect each other. We don't know if they're perpendicular or not. We don't know if they bisect angles, but they do bisect each other. In other words, they have the same midpoint. So keep that in mind. We have to know that it's a rhombus in order to make all these fancy conclusions. Yeah, we're going to hear bells ringing today. Sorry about that. Doesn't mean class is over. Find the measurements of the numbers angles again. Very straightforward. So if this angle is 118, I know that 1, 2, 3, and 4 all have to be congruent. So I do have a little bit of stuff going on here, but again, since it is a rhombus, if I just take that bottom triangle, DGF here, rhombus means that these sides are congruent, and this is 118. Well, what do we know? We go back to our isosceles triangles theorems. Since these two sides are congruent, it means these two angles also have to be congruent. And since I had 180 degrees in each triangle and I subtract 118, that leaves me with 62 degrees, which must be split evenly between those two angles. So it's 31 degrees and 31 degrees. Pretty straightforward. So there's the diagonals of a rhombus for you. A lot going on with the diagonals of a rhombus. Diagonals of a rectangle have their own special property, and that is the diagonals of a rectangle are congruent. So diagonals of a rectangle are congruent. That's fantastic. That means since they're bisecting each other already, that all 4 of these half diagonals have to be exactly congruent. Now, you'll notice that my triangle here and here are definitely not congruent, unlike in a rhombus where all 4 of the inside triangles are congruent. Here, absolutely not. But the top and bottom triangle and left and right triangles are both congruent to each other. So you have 2 pairs of congruent triangles in there. Notice in a rectangle, the diagonals clearly do not bisect the angles. I mean, if I look at this angle right down here, it's obviously much different than this angle up here. So they are very different angles. So clearly the diagonals do not bisect the angles. Clearly the diagonals do not intersect to form a right angle either. So rectangle, very different property. The diagonals are congruent. It's probably a good idea to be keeping track of these little facts on a piece of paper somewhere. So listing the properties of a rectangle, for example. So maybe one thing you might want to do is make sure you have a card that says rectangle. And then special properties of rectangle, all angles congruent. Diagonals congruent, and then plus all parallelogram properties. The parallelogram properties are, again, opposite sides congruent, opposite sides parallel, opposite angles congruent, consecutive, angles supplementary, right there, and diagonals bisect each other. Okay. So it might be useful to do that for rectangles. I'll do that for rhombuses as well. Go back and list all the properties that are special to rhombuses. So you can have kind of a list of those to refer to. One application of the rectangle's diagonals being congruent is in construction. It's a very common one. Let's say you're framing a window for a house or a shed or whatever, and you set it up like this, and the sides measure out perfectly 44 by 33. Do I know that this is a rectangle? This is my window. They call it square, even though the shape is not a square. Are these right angles? Okay, that's what we're asking ourselves. Are those right angles in the window? Because usually it's pretty important that they are, because the windows are usually built square when they come in. So if your opening is not square, the window will not fit. So that's a pretty common question. How can I find if the window is square? Well, I could get out a big old, T-square or an L square, and I could put it in there and I could check to see if it's perfectly square. But there's actually an easier way. What we can do, and in construction, what you do is you measure the diagonals. And if those diagonals are exactly the same length, we know that that shape must be a rectangle, which means we have right angles in all four corners. Which means, yeah, the window's probably going to fit if we've cut the right dimensions. In this case, it says the diagonals are 54.8 and 55.3 inches, so a ½ inch off. So that opening is not square. And the window would not fit in that opening. We'd have to torque that wall to make sure that that is a square opening, or a perfectly rectangular opening. So that's an application of why we use the diagonals of a rectangle. You do any framing, any building, you will use that fact. Here's an application problem. So we're bookending today with the questions. Today's application question is this. I have a rectangle. I have QS. Notice QS is right here. I have RT, and RT is right there. What do we know about those two? How can we set up and solve that equation? That's how we're going to finish today's lesson, and we'll see you in class.